Okay, so let's take a look at some applications of radian measure, and we're going to begin by talking about arc length. Now, an arc length would be the distance on the outside of the circle here, and it is related to the radius of the circle and theta. So the arc length is determined by taking the radius of the circle, multiplying it times the amount of rotation that you had occurring, and that gives you the length of the arc. Think of this kind of like perimeter for trigonometry. So this is the formula that we would use. Here's the formal definition of it over here. The one thing you want to make sure that when you're dealing in arc length, you want to make sure that theta is in radians. So let's look at an example. So I have three examples here we want to look at to begin with. The first example gives you a picture, and if we know that the formula for arc length is given by S stands for arc length, S is equal to theta times radius. I know according to this picture here, for example A, that the radius is 11, and I can tell that theta is being given as 7 pi over 4. So I know theta is in radian measure, and I can just simply apply these to the formula. So it's kind of a straightforward multiplication problem. So I end up with 7 pi over 4, which is theta, times 11, which is the radius. And generally, when I multiply that out, I get 77 pi over 4. Now, if I wanted to know the exact answer, I would leave pi as it is, as a symbol here. If I wanted to know an approximate answer, since pi is on our calculators is approximated, then I could use my calculator to get an approximate answer. But we're going to leave it like this for now. Let's look at this next example over here for part B. So again, I want to find out, again, I'm solving for either the arc length or theta or the radius. Notice in this example, I'm given theta as radian measure, but I'm also given the arc length. So I'm going to work the formula kind of backwards. Here, if I know that S is equal to theta times the radius, and if I know that I'm going to be solving for the radius, then I'm going to go ahead and rearrange this formula right now because it's going to make my math just a little bit easier. So I would divide both sides by theta, and that would give me the fact that when I plug my numbers in, I'm going to have the arc length divided by theta to find out what the radius is. So if the arc length is 9 pi, and if I divide by a fraction, because I'm going to divide by theta, remember when I divide by a fraction, I multiply by the reciprocal. So I'm going to go ahead and flip this right now, because the reciprocal would be 4 over 3 pi. So again, if I have the arc length of S divided by theta, that's the same thing as multiplying by the reciprocal since theta was a fraction. So my 3 is going to divide into that. Theta cancels off, and I end up finding out that the radius of this particular circle is 12. Okay, the last example let's look at together is over here. This is example C, and I'm given what the radius is, and I'm given what theta is. The radius is 4.82 meters. And theta, now remember, theta is being given in degrees, so I need to make sure that I change this to the proper radian measure. So 60 degrees is actually equal to pi over 3 radians. So that's the value that I'm going to substitute in for theta here, pi over 3. And when I multiply these two values out, since I'm already given the radius in a decimal measure, I'm going to go ahead and multiply this out on my calculator using the pi button to represent the symbol here, and I find out that the actual arc length would be 5.05 meters. And that's just simply taking values off of what I'm given and plugging them into a formula.